Hello, this is Mr. Huber. In this lesson, we're going to learn about writing linear equations in point-slope form. Slope-intercept form, y equals mx plus b, requires a slope and a y-intercept. And that y-intercept is a very specific point, right? There's only one point where the graph would cross the y-axis. That very specific point isn't always easy to work with. Point-slope form, okay, point-slope form here, requires us to have any point on the line and the slope. So we still need the slope, but now we can have any point, not necessarily that specific y-intercept. So again, any point, x1 comma y1, and the slope, which we're still using as m. We can write point-slope form using any point and the slope as y minus y1 equals m, parentheses, x minus x1. So the y and the x will stay a y and an x. The x1 and y1 will be some point on the line, right? We'll get that from our point on the line. And our slope, the m, will go there. So y minus y1 equals m, parentheses x minus x1, is point-slope form. Let's look at how we can write some equations in point-slope form. So we're going to write an equation of point-slope form with the slope in this first one of -5 and through the point 4 comma -1. So we go back up here, we're going to have y minus y1 equals m times x minus x1. So let's label the parts here. So we have x1, y1, and m. So let's write our equation. Y minus. We're subtracting -1, so it's actually going to be plus 1. Y minus a -1 is plus 1 equals -5, then x minus 4. So you want to pay attention here to subtracting y1. So if we're subtracting, we put a -1 in here, subtracting a -1, we write as y plus 1. And then -5, parentheses, x minus 4. There's no negative sign to worry about making that a positive, x minus 4. So that's our x1, our y1, our m. All right, let's try another one. And you could write this out in point-slope form. So we're going to have y minus 5 equals 3/4, parentheses, x plus 2. And that's point-slope form. All right? We need a point, x1 and y1, we need the slope m, then we put that in for y minus the y coordinate from our point equals m in parentheses x minus the x coordinate from our point. Let's look at how we can graph something in point-slope form. Right? So we can read from our equation a point. So we need to be able to read from this equation what's a point that we would know is on the line. This is our x1, x minus x1. So we will have a point 4 comma -3, right? Keep in mind, right? This is y minus y1. So this is like having y minus -3. So our y1 value is -3. So we have a point 4 comma -3, and we have a slope of 2. So we can plot this point, right? We can plot any point on the line. We've plotted y-intercept and other points before. Let's start with 4 comma -3. So we're going to plot the point 4 comma -3. That will be right here. And then we're going to use our slope of 2 over 1. So we're going to rise 2 and run 1. Rise 2 and run 1, and we've got some points. We could go the other direction, down 2 and left 1. Okay, but we start by graphing this point. This is the point 4 comma -3. 4 comma -3. We got a point, and then from that point, we use the slope to get other points, and we can then graph this as a line. And there's our equation graphed. Okay? Find out the point that's on the line, use the slope to get another point, and draw your line through them. So in number 4, again, try this one out, see how you do on it. The point that we would have would be -6 comma 7. Right? You might start to recognize it's really going to be the opposite of the sign you see here. Okay? If we have x plus 6, that's like subtracting a -6, so our x value is -6. Y minus 7 is going to be a positive 7 for our y value. So -6 comma 7 is a point that's on the line. So let's plot that point. We're going to go over this way, 1, 2, 3, 4, 5, 6, and then down 7, 2, 3, 4, 5, 6, 7. And we're going to have a point right here. Okay? That's going to be our point, -6 comma 7. And then our slope is -2 over 5. So slope -2 over 5, we could go down 2 and to the right 5 and get a point right there. And we would have a line that goes through those points. Right? So plot the point from your x1 comma y1, identify from the equation, the point and slope form, what is the point x1 comma y1 that we know is on the line, and then use the slope, like we would other times, to rise and run and get a second point. So no point slope form, right? Y minus y1 equals m parentheses x minus x1. All right. Before we see some more point slope form, an acronym is something that stands for something else. So do you know what either of these stand for? M&M and SCUBA. Let's start with the M&M, that tasty little candy we see there. It actually is the last names of the founders of M&M candy, Mars and Murray. Forrest Mars was the founder of the Mars Candy Company, and Bruce Murray was the son of one of the presidents and founders of the Hershey Chocolate Company. So those two candy families got together and created M&Ms, and they called them that based on their last names being Mars and Murray, and that's where M&M comes from. Scuba, right? We see some people scuba diving there. I don't know if anyone else is scuba diving. I've never gone scuba diving. Looks interesting. Exploring there, scuba stands for self-contained underwater breathing apparatus, right? Because that's what that is, right? So you're breathing under the water, and it's contained on you. So self-contained underwater breathing apparatus. Maybe you knew that, maybe you didn't. That's what scuba stands for. And M&M. All right, let's write an equation in point slope form when we have a graph of a line. So point slope form, we need the slope still. No matter what equation we're writing, if it's slope intercept, point slope, slope is part of it. So if we don't know the slope, let's start there. So we're going to find the slope of this line by just counting a rise and a run. So I can go down 1 over 1. So negative 1 plus 1. So my slope will be negative 1 over 1. Okay? My slope for this line will be negative 1 over 1. If you wanted to count, let's say, from this point down 2 over 2, that's fine. Negative 2 over 2 would still come out to negative 1. So the slope here is negative 1. And now we were thinking, okay, point slope form, we need an x1, y1. Which one should it be? We could write using either one. So I'm going to write one using the point negative 1 comma 3. That would be y minus 3 equals negative 1 parentheses x plus 1. And then we'll write it using the point 1 comma 1. So I could have y minus 1 equals negative 1 times x minus 1. So no matter which point you use, this point slope form, they're both equations for this same line. You need any point on the line. That's one of the benefits. Any point on the line, you can write point slope form. And let's simplify this. Okay, we could simplify this by using distributive property, combining like terms. Let's get the y by itself. Okay, so if we did that here, we'd start by distributing the negative 1 into parentheses. We get y minus 3. Negative 1 times x would be negative 1x. And then negative 1 times 1 would be minus 1. And then I could add 3. I'm trying to get the y by itself, so I add 3 over here, and I'd get y equals negative 1x. I can just write it as negative x as well. I don't have to put the 1. Negative x plus 2. Right, that would be the equation slope-intercept form. We could look at it and see, does that make sense? Yeah, I get a y-intercept of 2. That's a y-intercept of 2. My slope is negative 1. That works. Okay. Let's do the same thing and simplify the second equation we wrote over there in blue. I can distribute the negative 1 into parentheses. I get y minus 1 equals negative 1x, and negative 1 times negative 1 would be a positive 1. And then when I add 1 to both sides, I'm going to get y equals negative x plus 2. The same slope-intercept form. Right, there's only one slope-intercept form for this line because it only has one slope and one y-intercept. But there's many ways we could write point slope form. They would all come out to the same equation. Right? If I graphed this or this, it comes out the same. Points that are solutions, which are points on the line that solve this equation, would also solve this equation. So these are both correct point slope form versions of the equation of that line. We can take any point on the line and the slope and write point slope form. If we simplify it, there's only one slope-intercept. Let's try another one. We're writing an equation, this time given 2 points. So again, what do we need to start with? The slope. In the last problem, we read the slope from the graph. Here we don't have a graph, but we're going to calculate the slope by doing y2 minus y1 over x2 minus x1. So we have 1 over 2. So my slope is 1/2. Right? That's my slope, 1/2. Right? Now I can write the equation in point slope form. Doesn't matter which one we use. I'm just going to take the first point, y minus 3. So I'd be using this one right here. Y minus 3 equals 1/2 parentheses x minus 2. Right? So that'd be the point slope form for that line. If I wanted to simplify it, I could. And if I wanted to write point slope form using the other point, I would have y minus 4 equals 1/2, still the same slope, x minus 4. So either of those would be correct equations for the point slope form for the line through those 2 points. Find the slope and then any point to write point slope form. Let's try to apply what we've been working on here. So we're designing stickers to advertise our new band. I'm sure we're awesome. All right, a company charges $225 for the first 1,000 stickers and $80 for each additional 1,000 stickers. So let's identify information from here. A point. We have a point here, 1, 225. I'm going to say this is in thousands, okay? So this is really 1,000. It's just going to make it easier instead of writing 1,000 in there, 1,000, 225. So 1,000 stickers, so we're writing this in thousands, all right? And $80 for each additional 1,000 stickers. So that's our slope. Our rate of change is 80, the cost per 1,000 stickers. So it's $80 for every 1,000 stickers. So an equation that we could write would be y minus 225 equals 80, then x minus 1. And if we wanted to solve this now, we could, or simplify this, excuse me, not solve it, simplify it, we'd have y minus 225 equals 80x minus 80. And then I could add the 225 on both sides, and I get y equals 80x plus 145. Okay, so I'm getting charged $80 for every 1,000 stickers. Remember the x is in thousands, so $80 for every 1,000 stickers plus 145. That's that initial cost, right? So there's some cost to get things set up at the beginning, right? That's our initial starting amount, and then our rate of change. So same thing we had before, and we could get there by starting with point slope form because we know a point and we know the slope, the rate of change. And now we could use this equation to find the cost for 9,000 stickers. When I plug this in, I'm not going to plug 9,000 in for x. I'm going to plug a 9 in for x because this is in thousands. So find the cost for 9,000 stickers. Okay, I'm going to do that right here. So I'm going to have y equals 80 times 9 plus 145. Okay. So 80 times 9 is 720 plus 145. And so that equals $865. So $865 to get those 9,000 stickers. We pay the 145, that's some kind of starting amount cost, and then 80 times 9, because 9,000 stickers, right, we wrote that in thousands, that would give us our total cost. So find a point, right, read from this. We're plugging in, we get in 1,000 stickers, we know out the total cost. So think about what is an input and an output there. Okay, what determines the other one? The number of stickers determines the cost, right? The cost is a function of, so the function of the number of stickers. The stickers is the input, the 225 is the output. And then 80 is our rate of change. We can write an equation here in point slope form and then get that in slope intercept form because we want an equation that gives the total cost. Y is our total cost for the stickers as a function of the number of stickers orders, again, in thousands. So read from those application problems, rates of change for slope, inputs and outputs for your x and y, and then we handle it like we were the other problems. And here we're learning about point slope form. So once we had a point and a slope, we could write our equation in that form and go from there.